Thanks, everybody. I am Laurie Voss. I am the VP of Developer Relations at LIamaIndex. In a former life, I co-founded NPM Inc., so you may remember me from when I used to talk incessantly about JavaScript. Now I talk incessantly about AI. Either way, I talk incessantly. Today, I'm going to quickly introduce you to LIamaIndex. I'm going to talk about what it is, why you should use it, and what it can do for you, including retrieval augmented generation, world-class document parsing, structured data extraction, and autonomous agents. We're going to talk about multi-agent systems, and we're going to talk about putting them into production. Just quickly, hands up if you write code on a regular basis. All right, okay. So there are a lot of code samples. I'm going to mostly be breezing through them because you have had a lot of patience, but I'm not going to exhaust it by walking you through code one by one. All of the slides that I'm presenting this evening will be shared at the end, as they said, and all of the resources have links attached to them. So what is LIamaIndex? It is a bunch of things. Starting with the most obvious, it is a framework in Python and TypeScript that helps you build generative AI applications. The Python framework is bigger and older. The TypeScript framework is growing fast. Both are obviously open source and free to use. But that is not all that we do. Llama Parse is a service from LIamaIndex. Earlier, we had a question from somebody who was asking, oh, I have thousands of documents. Each one of them is hundreds of pages. What do I do to prepare this data to be run through a RAG system? Llama Parse is the answer. It turns out that complicated documents like PDFs, Word files, PowerPoint presentations, they are not easily understood by LLMs. You get demonstrably better results if you pre-parse this data into a form that the LLM can understand, and that is what Llama Parse is designed to do. It is designed to spoon feed data to an LLM so that it understands what it's looking at, especially when you're talking about complicated tables, images, text that's been rotated, stuff like that. Then there's Llama Cloud, which is our enterprise service. Oops, I used a slide from a hackathon instead of a regular slide. If what you want to do is you are an enterprise and you want to stuff documents in one end and get a RAG pipeline out the other without having to think about any of the stuff in between, you don't want to have to think about scaling it or making it reliable or configuring it, then that is what Llama Cloud is designed to do. It is available as a SaaS and as an on-prem offering. It is designed to be turnkey for an enterprise that has a whole bunch of unstructured data and is trying to make sense of it. We also have a thing called Llama Hub. It is a registry of helper software. If you want to connect to any database in the world, we've got that. If you want to get your data out of Notion or Slack or Salesforce, no problem, we've got that. If you need to connect to if you need to store your data in a vector store, and you do, and we have integrations with Pinecone and also all those other LLMs, those lesser LLMs. We also support every LLM that exists. Over 30, including OpenAI, Mistral, Anthropic, Ollama for local LLMs, anything like that. And if you are building an agent, we have a bunch of pre-built agent tools that you can download from Llama Hub, so you don't have to build your own agent tools to connect to various services. All of which is to say, why should you use LIamaIndex? Because it will help you go faster. You are trying to solve actual business problems, and you do not want to get stuck writing the boilerplate. You do not want to get stuck solving problems that everybody else has already solved before. You have novel business problems that your business needs to concentrate on. That's what a framework is for. A framework smooths over the rough edges and takes care of the problems that everybody already knows about. So let's talk about what LIamaIndex can actually do for you. Our previous speakers have already defined RAG for us, so we don't need to go into that. So let's talk about how you build a RAG pipeline in practice. Very, very quick 10-second recap. You ingest your data, you parse it into chunks, you embed those chunks, you store them in a vector store, you use a query to perform semantic search on the chunks in your vector store Then you take those chunks out of your vector store, you feed them to an LLM, and you get a response, hopefully without hallucinations. Let's look at how you do that in LLamaIndex. First, you need to get your data from somewhere, whether it's your file system, a database, or an API. Our connectors will do all of that for you, and they'll turn them into interoperable document objects, so you don't need to have to figure out how to make your RAG system work on text and images and audio and all of that other stuff. The next step is parsing. We have a bunch of built-in parsers, but like I said, the real secret weapon here is LlamaParse. It's going to take documents that your LLM can't understand and turn them into a form that it can. Next, you have to embed your data. You can use third-party APIs like OpenAI to do this, or you can use local embedding models downloaded from Hugging Face. We provide a one-liner that lets you do that. And once your data is embedded, you have to store it in a vector database. We integrate with every vector store that exists. So whichever one you decide to choose, we will support it, and we'll take care of it for you. To use your embedded data, you need to query it. LlamaIndex will embed your query for you, give you a query engine that runs your query against, that retrieves your data, runs your query against the LLM, and gives you the response back. Again, it's a one-liner. Your retriever, however, is completely customizable. So if you want to do stuff like re-ranking, you can do that. And of course, like I mentioned, we don't just do all of this stuff for text. We can also do it for images. We can do it for audio. We can do it for video. Slightly cheating with the video. We tend to turn it into a bunch of images and then do it for images. If what you want to do is you want to create a chatbot that talks to a bunch of documents, that is an extremely common use case. It is what a lot of people want to do. That is a one-liner in LlamaIndex. You run npx create llama, and it will give you a bunch of choices from a bunch of templates to put together a full front and back end full stack application that will create a chatbot for you and let you ask questions about the data that you have stuffed into it. It's extremely customizable. It's a great starting point, especially if what you're trying to do is create a demo that is going to, convince the people with budget that this LLM thing is worth taking on. But the point of this talk, indeed the point of LlamaIndex in general, is that there is more to this problem than the 5 lines of code I just showed you. If you were paying attention, you noticed that I got from one end of the RAG pipeline to the other end of the RAG pipeline in 5 lines of code. That is the benefit of a framework. We get there really, really fast. You can turn each of those lines into a whole page of code if you want to, but you don't have to. But naive RAG is limited. It tends to work for simple questions over small sets of documents, and there are a number of ways that naive RAG can fail. One task it's not great at is whole document summarization. RAG is necessarily a search mechanism. You're looking for chunks of your document that are related to your query, and then you are using the LLM to take those chunks and summarize them. But what if you want to know about what is happening with my document as a whole? That's not what a RAG system is set up to do. It is set up to answer questions about relevant pieces of your document, not about your entire document. Another task that's tricky for a strictly search-based RAG pipeline is comparison. If you've got a bunch of data, for instance, about multiple people, and you have a single query that asks the LLM to compare these people, it's going to retrieve chunks that are relevant to all of those people at the same time, but it's not necessarily going to know which chunk is about which person. So it's going to start confusing attributes of these people with each other and not necessarily creating the comparison you wanted. And more generally, naive RAG fails at multi-part questions. If you ask your pipeline to summarize the arguments of article A against the arguments of article B and put them in a table and compare them, it's going to get very confused trying to do all of that stuff in one go. That's just not what RAG can do. Which isn't to say that RAG is useless. It's extremely useful. It's an incredibly helpful building block for more complicated systems. It is necessary, but it is not sufficient. Lots of tasks require semantic search and completion, but lots require more than that as well. So how do we go beyond the limits of RAG to fully utilize the power of LLMs? There's two avenues of improvement that we can follow here. The first is to improve the data quality, and that's one of the reasons that we built LlamaParse. Just by making your data easier to understand, you can get a lot further. The second way is to make your querying more sophisticated, and that's what I'm mostly going to be focusing on for the rest of this conversation. The way we're going to be improving our querying is by using agentic strategies. Agents is a term that is overused in this industry to the point of being meaningless. So when I use it, what I mean is semi-autonomous software that can be given a goal and it will work to achieve that goal without knowing in advance exactly what steps it's going to take to achieve that goal. You give it a set of tools, you give it some data, you give it a goal, and you let it figure it out. So let's talk about agentic strategies and how we can build them into our system, working our way up to a full-fledged agent. Like I said, a naive RAG pipeline has a bunch of limitations. It's single shot, so there's just one question and one response. There's no query understanding, it's just semantic search. There's no tool use, so you can't go and seek more information about the state of the world to be able to answer your question. And by default, there's no reflection or error correction. The pipeline does not check whether it really answered the question. It just gives you its best attempt. And finally, there's no memory. In a naive RAG pipeline, every question is brand new. It doesn't know what previous questions you've asked. We can fix all of those. By building agentic RAG, you can do a whole lot better on every front. You can make your queries multi-turn. You can have the agent understand the question, and plan how to get to the answer in multiple steps. You can make RAG just one of many tools, allowing you to interface with the wider environment and other sources of data, and you can use reflection to figure out if the answer that your pipeline has provided is actually worthwhile, and if it's not, you can course correct, or you can ask again, you can rephrase your question. Getting all of that done is a lot of work, but it is work that LLamaIndex does for you. The strategies I'm talking about exist on a spectrum of complexity, from very simple and cheap to implement to much more complex and more expensive to implement. And by expensive, I mean in terms of compute, but also actually in terms of money. Some of these are not fully agentic by themselves. Some of them are just, some are just components that you need to make an agent, but we're going to break this down and go through each of these in turn. But quite quickly, because your patience surely is exhausted at this point. It's been a long evening. First up is routing. The simplest form of agentic reasoning. Given a query and a set of basic tools, the router uses the LLM to select which of the tools available is the best to answer the question. This can solve the summarization problem. For instance, you can give your LLM a set of tools that includes, here is a RAG pipeline that will answer questions about specific chunks, and also, here is a full summary of the document. And your LLM can decide, based on what the question is, whether or not it should be doing RAG queries or it should be providing a full summary of the document. This is built into LLamaIndex as the router query engine. This is a very abbreviated code sample of that in action. You can see us creating two tools, one of which is a regular RAG query engine, and the other is specifically a full document search. A full document summary. We provide both as tools to the router and then let the LLM pick. This solves the routing problem, but it is still one shot. The next tool that we can add as we build up to an agent is memory. This is theoretically simple. As you run queries, you include them in your history, and as you add additional queries, you provide that history to the LLM when you're providing your additional queries. So every time you get a response, it has the context of, here are all the questions and answers that we previously answered. There is some subtlety to that because obviously LLMs have limited context windows. So as your history gets long, you have to start condensing that history down to summaries of what was going on for it to be able to answer the questions. And again, this is built into LlamaIndex. This is almost identical to the 5-line starter that I was showing you earlier. instead of a query engine, we create a chat engine, and instead of query, we run chat. This is doing a whole bunch of stuff for you under the hood to take care of memory and make sure that your LLM has context. Then we can add one-shot query planning. This takes a complex question and breaks it up into simpler questions, each of which can be run in parallel without conflicting with each other. Then you can take the resulting responses and get the LLM to aggregate them into a single adequate response based on far more context than trying to do it all in a single giant query. The built-in here that does this is called the sub-question query engine. What you do is you give it RAG query engines. You can give it as many as you need, and you give the LLM metadata describing what does this RAG query engine know about, and provide an array of them to the sub-question query engine, which will execute, like I said, all of these questions in parallel, and then aggregate the responses into a single response. The router query engine and the sub-question query engine are two specific examples of the biggest part of making agents and agentic RAG effective, which is tool use. I talked about the definition of an agent being, from my perspective, a piece of software that knows how to use tools. You can describe an arbitrary API to an LLM and get it to infer the parameters of that API and then get it to call that API. That is an amazing leap forward in software. You can describe a tool to an LLM and it will use the tool. It can get additional information about the state of the world. It can also change the state of the world. It can take action. My favorite example is, it can read your emails for you and not just tell you you need to set up an appointment. It can, call your calendar API and set up an appointment for you based on that. Tool use doesn't just have to pass a query. Tool use can change the shape of what it is that you are doing. In auto retrieval, for instance, we talked about this earlier, you can take a query and you can pre-filter your data based on the metadata that's available. If you are doing text to SQL, you can take a natural language query and get the LLM to convert it into a valid SQL query that it runs against the database. Or you can just basically take your query and convert it into whatever API it is that you're talking to, a valid call to that API. In these examples, we've already seen examples of tool use in LIamaIndex. Those both used RAG engines as tools, but this one is an example of just using an arbitrary Python function called multiply as a tool. You can create any arbitrary Python function as a tool and get your LLM to be able to use it. These can be arbitrarily complex, which makes it a really, really powerful ability to add to your software. So now we've seen the basic agentic strategies, but they are just the minimum necessary to create an agent. We need to go further. We need to make it multi-turn. Let's give it reasoning and planning. Let's give it reflection, and let's talk about how we get this done. There's 3 types of agentic reasoning loops that I want to talk about very briefly. Sequential, DAG-based, and tree-based. These, again, they live on a spectrum of simplicity to complexity and cheapness to expensiveness. The first is sequential. In this one, you generate your next step based on your previous steps. One of the most popular patterns here is called React, not React the web framework, but reasoning plus action. We already saw it when I demonstrated tool use. In React, the agent generates this distinctive pattern of it generates a thought, it comes up with an action, and then it takes that action and makes an observation about what the result of that action was. It just stays in a loop doing that, having a thought, taking an action, making an observation over and over until it either achieves its goal or it gives up. You can see this in action in this output. I've told it to do a math equation where it multiplies 2 by 4 and then adds 20 to it or something. I can't remember exactly what the math equation was. I probably should have included that. But you can see it. It says, I need to use a tool to answer the question. What tool am I going to use? I'm going to use the multiply tool. I'm going to take here's my input, here's my output. Now I need to use the add tool. I need to add 20 to that number. It gets 28. That is very basic tool use in action. The next step in planning and reasoning is a DAG-based planning agent. To back up for a second, a DAG is a directed acyclic graph, which if you didn't do computer science, you can think of basically as a flow chart, a bunch of boxes with arrows between them connecting them to a plan. In DAG-based planning, the LLM comes up with a full plan from start to finish from where I started to how am I going to solve this problem. And it does that by coming up with a DAG that looks kind of like a flow chart. A critical part of this planning is the ability to replan when things don't work out. So the LLM can observe, is my plan going according to plan, or do I need to change it and generate a new DAG? This ability to self-evaluate is called self-reflection. The LLM can tell whether the LLM is doing a good job, which is, again, a pretty amazing thing for a piece of software to be able to do. You can, of course, also get a human in the loop to say, you are doing a good job or not. Once again, doing this in LIamaIndex is simple. We've created two tools in advance here. One is a bunch of information about Lyft. One is a bunch of information about Uber. And we've asked it a complicated question. Summarize the key risk factors for Lyft and Uber in their 2021 financial reports. This is a comparison question. It needs to know about both of those things to be able to answer that question. In this output, you can see what the DAG does. It creates an initial plan that consists of extract Lyft's risk factors, and then extract Uber's risk factors, and then combine the risk factor summaries. And you can see in the dependencies array there, it said that, in this graph, these two things need to have happened first before this third thing can happen. That's a very simple, just triangular DAG, but it can create arbitrarily complex graphs to be able to solve a problem. But still, DAG-based planning works best when the problem is still simple enough that the LLM can see its way from the beginning to the end of the problem all in one shot. That is not necessarily the case with real-world problems. With real-world problems, it might not be clear how you're going to solve this problem to start with. In that case, you can use tree-based reasoning. There are several different variants of this, including tree of thought, reasoning via planning, and language agent tree search, which is the one that we built into LIamaIndex. But they all have some fundamentals in common, which is that they don't know in advance how they're going to solve this problem. So instead of building a single plan from start to finish, what these agents do is they create experiments. They say, okay, here are 3 things that I could do. How do I think the world is going to change after I do those 3 things? And then for each of those 3 things, they think, what are 3 more things that I could do? And how would the world change if I did those things? And so on down the tree simultaneously. And then it can look at all of this, it can look at this tree of possibilities that it's created and said, okay, I think that one is the one that's going to get me closest to my goal. Let me follow that out. Like I said, this is implemented in LIamaIndex as language agent tree search. As we did with structured planning, we create a worker from a set of available tools. The expansion parameter that we're seeing here is the number of branches it will create simultaneously, whether it's 3 or 5 or 7 different possibilities it will explore. And the rollouts is how deep down the tree it will go before deciding that it has to pick something. So now we've got pretty deep into LIamaIndex. We've built a RAG pipeline. We have built agents that can use RAG pipelines. And the last thing that we're going to cover today is workflows. Workflows allow you to build upon these patterns and create more complex LLM applications. Specifically, what it allows you to do is create multi-agent systems. The agents that we've been building so far are very complicated pieces of software, but you can get even further by creating multiple agents that have different specialties and getting them to coordinate with each other and communicate with each other. Why do we need this extra feature in the framework to be able to do that? It's because when applications get big, they get complicated, and we as a framework are growing to meet that demand. How your agents are going to interact needs to be defined. You need to be able to debug and visualize that interaction, and you need to be able to customize those interactions to meet the specific needs of your application. And these are the problems that workflows were intended to solve. The most basic workflow looks like this. A workflow is composed of steps. You can have as many as you want. You create a class that holds all of your steps. The steps are marked with a decorator. And they use just type descriptions to specify what events should trigger them and what events they should emit. So in this most basic example, I've created a function called generate and marked it as a step. It accepts a start event and it emits a stop event. So this is a workflow that just does one thing in one line and then does nothing else. One of the most important things you can do with workflows is that you can't do with graph-based attempts to solve this kind of problem is that you can do loops. DAGs are acyclic, so they are, by definition, they're not good at doing loops. In this simplified example, you can see how a loop works. You can see we now have two steps. The first accepts a start event, and it tries to answer the question. In this case, I'm using random numbers to simulate whether or not it was able to answer the question. If it gets a bad answer, it emits a failed event, and that will trigger the improve query step, which will try and come up with a better query, and then emit a query event, which gets picked up by answer query again. So it can go through this over and over until it gets a good query. If it answers the query correctly, it emits a stop event. If it can't improve the query, it also emits a stop event. And all of the possible flows of this very simple workflow are visualized in this diagram. One of the things that we quite like about workflows is that they have visualization built in. So you can just call a single line of code and you get this interactive diagram of what it is that your workflow can do. And this diagram can handle arbitrarily complex workflows, which makes it a really great debugging tool. In addition to passing events around, there's also a global state. So your agents can share a state, for instance, a pile of data that they all need to be able to access can be put into the state and they can access it separately. As you can see here, I'm using Simple Directory Reader, which I showed you in the 5-line starter, to create an index that all of the agents will then be able to access. So the examples I'm showing you here are necessarily very simple because they needed to be able to fit on a slide. But keep in mind that these steps can be arbitrarily complex. Each one of these steps can be an agent in its own right, taking input and making decisions. Each one can define and use a RAG pipeline. Each step can use built-ins that I showed you, like Sub-Question Query Engine and others. So when you're building your first app, you can be linear, but as your flows get harder to keep track of, this is the tool that workflows are the tool that we expect that you will begin to reach for. As workflows mature, we're going to be releasing pre-built workflows to implement common design patterns. With those in hand, you'll be able to customize them to meet your own specific needs. This is because workflows are class-based. You can just take any workflow that exists and customize this, subclass it to customize the steps that you want to change. I want to point you very quickly, you're going to get the links to all of these at the end, to some really great examples of workflows in action. The first is a multi-agent workflow. This creates one agent that researches your blog. It writes blog posts for you, basically, is what this workflow does. One will research your blog post by performing web search. One will write the blog post, and the third one will critique the results of the other two. It provides multiple mechanisms for coordinating between those agents, and it's a really useful example of how you can put together, how you can use multiple agents coordinating with each other to be able to solve a more complicated question that a single agent would not be good at. The second one is one that I put together personally called the multi-agent concierge. This was based on an actual customer problem that somebody asked us to solve. What this does is it creates multiple separate agents which have different specialties for solving customer problems in a customer support bot. And then there's a single orchestrator agent which, given input from a user, decides which of these other agents is going to best be able to help the customer with this problem and routes them to that agent, which then can ask them questions until it solves that problem and bounces them back to the orchestrator. And the last one is a full stack application, front end and back end, both written in Python. The front end is written in a newish framework called Reflex. This provides a full agentic system for enhancing queries that are going to a knowledge base. Like I said, if you want to build a chatbot, don't. Use Create Llama to build a chatbot for you. It's going to be much faster and it's going to get you exactly where you were going to go in a fraction of the time, and then you can focus on building, on solving your real business problems. But the title of this talk is Multi-Agent Systems in Production, and so far we've got to multi-agent systems and we haven't put them into production. So that is the very last thing that we are going to do. We have a system that helps you deploy workflows. It is called Llama Deploy, because at LIamaIndex, everything is called Llama something. The basic idea of Llama Deploy is that your workflow gets deployed as a microservice. You can have as many workflows as you want, and it will deploy them all automatically as separate microservices that you can scale independently of each other. And each of these workflows can be one or many agents. The system gives you automatic retries and a bunch of other features that make them resilient for production use. To deploy something with deploy a workflow with Llama Deploy, the first thing you do is you deploy the control pane. I'm not going to step through this code, but you can see it's 4 lines of code plus some boilerplate. And once you're done, you can deploy as many workflows as you want. Just give them hosts and ports like any other web service, and they will bind to those and start chatting to each other over the control plane. Your control plane has a queue system. It can be elastic or it can be something simpler. But the result is you don't have to think about how am I going to get these agents from a notebook into production. That problem is now solved for you. You can just turn them into a web service that can talk to each other and talk to your front end and talk to your client. Because where things get really interesting is when we introduce nested workflows. Workflows can run other workflows. You can pass them workflows. And Llama Deploy will automatically spin up each nested workflow as its own service to be scaled independently of the parent workflow. And you can do all of this without any additional code on your part. Llama Deploy is the newest feature of LIamaIndex, so we are actively seeking feedback on how it feels to work with it. So please head to the repo, try it out, and let us know what you think. We're very excited about it. So this is all the stuff that we covered today. I'm not going to recap the recap, but there's a whole bunch of stuff that we didn't cover, like observability and evaluation. So I'm glad you were here to take care of that. What's next is up to you. We are excited to see what you can build with all of this. We welcome feedback from the community. And that the open source community means you, everyone in this room. You can join our Discord. Our engineers hang out there all the time and answer questions surprisingly quickly when they should be working. And we also have extensive documentation that I've personally spent a lot of time writing, so we welcome feedback on that as well. All of these slides and examples are available at this link, or if you follow that QR code. I hope this has been a useful introduction to LIamaIndex to you, and also an introduction to the wider world of retrieval augmented generation and AI-powered agents. It's been a pleasure to speak to you. Thank you for staying all the way to the end, and thank you for your time and attention.